Hey everyone, and welcome back to the channel. Today, we're diving deep literally into one of the most fascinating and powerful places on Earth, Yellowstone National Park. We all know it for its incredible geysers, like Old Faithful, and its stunning hot springs. But beneath all that beauty lies something truly immense and mysterious, a supervolcano, and for decades, scientists have been trying to map out its fiery heart. The big question has always been, what exactly is lurking under Yellowstone? For a long time, the picture was incomplete. We knew there was a massive magma plume rising from deep within the Earth's mantle, feeding the volcanic system. We also had evidence of a large, shallow magma chamber, sitting just a few miles beneath the surface. Think of it like a giant pancake-shaped body of hot, partially molten rock. This shallow chamber is what fuels the famous geysers and hot springs. It's the engine room for all the surface activity we see. But scientists suspected there was more to the story. The amount of heat and gas, like carbon dioxide, escaping from Yellowstone just didn't add up. If only this one chamber existed. The numbers were too high. There had to be a missing piece to the puzzle. Where was all this extra heat and material coming from? The challenge was figuring out how to see what's miles underground. You can't just drill a hole into a magma chamber. So, scientists had to get creative. They turned to the Earth's own seismic waves, the vibrations from earthquakes. Earthquakes happen all the time, both near and far. When these seismic waves travel through the Earth, their speed changes depending on the material they pass through. They move slower through hot, molten rock and faster through cold, solid rock. By setting up a dense network of seismometers all across the park and beyond, scientists could listen in on these vibrations. It's like giving the Earth a CT scan. They measure how long it takes for the waves from a distant earthquake to reach each station. If a wave arrives later than expected, it means it probably traveled through a hot, gooey zone. And what they found was absolutely groundbreaking. Using this technique, called seismic tomography, they discovered a second, much larger magma reservoir hidden deeper beneath the first one. This newly discovered chamber is a true behemoth. It's located between 12 and 28 miles deep, and its volume is enormous, over 11,000 cubic miles. That's about 4.5 times larger than the shallow chamber we already knew about. To put that in perspective, that volume is enough to fill the entire Grand Canyon almost 11 times over. It's a staggering amount of molten and semi-molten rock. Now it's important to clarify what we mean by magma chamber. Don't picture a giant underground lake of liquid lava. That's a common misconception. In reality, these chambers are more like a hot, rocky sponge. They are a mixture of solid rock, crystals, and only a small fraction of actual molten liquid, maybe somewhere between 5 and 15%. The rest is superheated, solid but ductile rock. So it's not a sloshing pool of lava, but a massive region of hot, mushy material. This deep reservoir is the main holding tank for the magma that originates from the mantle plume. It's the primary source that slowly feeds the smaller, shallower chamber above it. This tutored system completely changed our understanding of Yellowstone. It solves the mystery of the excess heat in carbon dioxide. The deep reservoir acts as the long-term storage, while the shallow chamber is the more immediate staging area for any potential volcanic activity. Material from the deep chamber slowly migrates upward, recharges the shallow one, and keeps the whole system ticking. This explains the long and powerful volcanic history of the region. So, what does this discovery mean for the big question on everyone's mind? Is Yellowstone about to erupt? The short answer is no. Probably not in our lifetimes, or even our great-grandchildren's lifetimes. Discovering this second, larger chamber doesn't increase the risk of an eruption. It's been there all along. We just now have the technology to see it. In fact, understanding the full plumbing system gives scientists a much better ability to monitor the volcano for any signs of change. They can track the movement of magma between the two chambers, watch for ground swelling, and monitor gas emissions with much greater context. It's like a doctor finally getting a complete diagram of a patient's circulatory system. It doesn't mean the patient is sicker. It just means the doctor can provide much better care and monitoring. Yellowstone has had 3 massive caldera-forming eruptions in its past, one about 2.1 million years ago, another 1.3 million years ago, and the most recent one about 640,000 years ago. These are unimaginably large events that dwarf any eruption in recorded human history. While the system is still very much active, geologists see no signs that it's building towards another super eruption anytime soon. The ground isn't deforming at an alarming rate, the seismic activity is within normal background levels, and there's no indication that a huge amount of magma is suddenly moving into the shallow chamber. For a super eruption to occur, a significant amount of that rocky sponge would need to become much more molten, creating a truly eruptible body of magma. That process takes thousands of years, and we would see clear warning signs long before it happened. What's more likely are smaller events. Yellowstone could experience hydrothermal explosions, which are steam-driven blasts that can create craters a few hundred feet across. These happen when water underground is suddenly heated and flashes to steam. These are localized events and happen every few thousand years. The other possibility is a lava flow, which is much less explosive than a super eruption. The last lava flow at Yellowstone was about 70,000 years ago. These are still serious volcanic events, but are nowhere near the scale of a caldera-forming eruption that would have global consequences. The work at Yellowstone is a perfect example of how science moves forward. A persistent mystery, the missing heat source, led to new questions, which drove the development of better technology, which ultimately led to a revolutionary discovery. This new, more complex picture of Yellowstone's plumbing allows for more accurate hazard assessment and monitoring. Scientists at the Yellowstone Volcano Observatory are watching the giant 24/7, using GPS to track ground movement to the millimeter, analyzing gases, and keeping a constant ear on its seismic heartbeat. This incredible discovery hasn't made Yellowstone more dangerous. It's made us smarter and safer. It is a testament to human curiosity and our drive to understand the powerful forces that shape our planet. The sleeping giant beneath the park still holds many secrets, but with every piece of data, we get a little closer to solving its volcanic mysteries. Thanks so much for joining me on this deep dive beneath Yellowstone. If you found this as fascinating as I do, hit that like button and be sure to subscribe for more science explorations. Let me know in the comments what other geological wonders you'd like to see us cover next. Until then, stay curious.